So today we're going to go over the symmetry of polar graphs. Looking back at Module 5 at the even and odd identities, there are two things you need to pull from there. Sine of negative theta equals negative of sine of theta, and the cosine of negative theta equals cosine of theta. I don't know if you remember even and odd identities in Module 5, but even and odd functions were also in Module 1. Cosine is an even function because if you replace the cosine of negative theta, you'll also get the same as if it were positive theta. So remember, f of negative x equals f of x as an even function. So all of that's going to come back a little bit. Now, how do I test if something is symmetric with respect to the x-axis, meaning one side of the x-axis looks exactly like the other side of the x-axis? For the y-axis, if it's symmetrical, that means one side of the y looks like the other. It's just like a mirror, like a parabola. You know, one side of the y-axis looks just like the other side. And with the origin, that would mean that it's symmetric with respect to the origin, meaning whatever's in quadrant 1 looks the same as in quadrant 3. Like a line, a linear function would be symmetric with respect to the origin. But since we're dealing with polar graphs, there is a test, and we're just going to replace r and theta with each one of these. And if it comes out the same as it was before, then it's symmetric with respect to that given axis that we're testing. So starting off, I'm going to test if it's symmetric with respect to the y-axis, which can be also called theta equals pi over 2. Because if you think about pi over 2, it's right up here, which is where the y-axis is. So I'm going to replace the r with negative r and the theta with negative theta. So I'm going to write negative r equals 3 plus 2 times cosine of negative theta. Well, I already know the cosine of negative theta up here is positive cosine of theta. I'm going to drop everything else down, and I'm going to get r by itself. Well, technically, r is being multiplied to negative 1, so to get rid of that, I'm going to divide everything by negative 1, and that'll give me r equals negative 3, because I divide each term by negative 1. Terms are separated by the plus and minus sign, so 3 divided by negative 1 is negative 3, and 2 divided by negative 1 is negative 2 cosine of theta. Needless to say, this is not the same as the original, so it's not going to be symmetric with respect to the y-axis. From here, I'm going to test out, let's say this one. Is it symmetric with respect to the x-axis, which can also be called the polar axis? Remember, when you're dealing with polar graphs, everything has kind of different names every now and then, so you just know that it means the x-axis, though. So from here, I'm going to change the r. Well, I'm going to keep it as r, but I'm going to replace the theta with negative theta. So r stays the same, 3 plus 2 cosine of negative theta. And again, I know that this, from the even and odd identities, is cosine of theta. Bring everything else down. R is already positive, so nothing needs to change here. It does happen to be the same as it was before as the original, so that means it's symmetric with respect to the x-axis. And that's it. Hope this helps, guys.